A machine in America has figured out how to make a pair of prescription glasses without a warehouse full of frames, without shipping the order to a distant optical lab, and without making the customer wait a week. You look into a scanner. A licensed doctor reviews the results. A second camera maps your face. Then the machine builds the frame, forms the lenses, checks the prescription, and hands you a finished pair before you have completed a trip around the store. The system is called the ClearForge Vision Cell. A basic pair costs $29. The median production time is 21 minutes. Almost nothing in the finished product existed before the customer walked through the door. And if a machine like this ever works at scale, the most expensive object sitting on your face may be headed for the same place as the photo lab, the video rental store, and the 1-hour film counter. Before we go any further, there is one line you need to know. ClearForge Systems and the Vision Cell are a fictional technology scenario. The pilot, the founders, the prices, and the fluid cast lens process you are about to see are invented. But the technologies beneath the scenario are real. American companies are already putting rapid vision testing kiosks into retail locations. Portable devices can already measure objective refraction in seconds. Licensed doctors can already review vision data remotely. Custom frames can already be manufactured from digital files. And federal rules already give patients the right to take their prescriptions somewhere else. ClearForge simply asks what happens when someone connects all of those pieces and solves the one part nobody has yet compressed into a retail machine, the lens itself. Stay with me, because by the end of this video, you are going to understand why a pair of glasses can cost hundreds of dollars even when the raw material is inexpensive. You are going to see why the real breakthrough is not printing plastic. It is removing inventory, shipping, repeated measurements, and the invisible handoffs between the exam room and your face. And you are going to see why the machine that threatens the eyewear system cannot be allowed to pretend that an eye test is the same thing as eye care. So let us start with the number that makes this entire story possible. $29. That is the fictional price of a basic ClearForge pair, including a custom frame, standard single-vision lenses, doctor review, assembly, and quality inspection. It is not the claimed factory cost of a Ray-Ban. It is not a statement that every $300 pair of glasses is a scam. It is the price a new system might reach if it made the product only after the customer arrived and removed most of the journey between prescription and delivery. Because the price of glasses is not just the price of plastic. It includes the frame design, the lens blank, the coating, the edging, the optical lab, the brand license, the sales floor, the inventory that does not sell, the inventory that is stolen, the shipping between facilities, the insurance paperwork, the remake when a measurement is wrong, the warranty, the marketing campaign, and the rent on the store where the frame waits for someone with the right face to walk in. That does not mean the current price is always justified. It means that if you want to collapse the price, you cannot simply find cheaper plastic. You have to redesign the system. And the current system is enormous. EssilorLuxottica sits across many layers of global eyewear. Its portfolio reaches from lens technology to famous frame brands and major retail networks. The company reported roughly 28.5 billion euros in revenue for 2025, then reported revenue growth of 9.7% at constant exchange rates in the first half of 2026. That is not evidence of a secret plot. It is evidence of scale. Scale gives a company better purchasing power, broader distribution, more data, familiar brands, and the ability to place products in front of customers almost everywhere. It also makes the existing process feel inevitable. You get an exam in one place, choose a frame from a wall, add lens options, send the order away, and wait. When the glasses return, they look like one product. Operationally, they may be the result of several businesses. several facilities, and several transfers of data and material. The American eyewear market has already tried to shorten that chain. The one-hour optical store shortened the wait. Online retailers shortened the showroom. Direct-to-consumer brands simplified the price and built their own laboratories. Warby Parker says its prescription glasses begin at $95, and by the end of 2025, it operated 2 in-house optical laboratories and more than 300 stores. That was a major change, but it did not eliminate the lab. It reorganized the lab. You could order from a website instead of a traditional optical counter, but the frame still had to exist in a size and color. The lenses still had to be processed. The finished product still had to move through a fulfillment system. The customer gained choice, but the physical journey remained. ClearForge begins with a more radical question. What if the lab did not become more efficient? What if the lab came to the customer to understand why that idea is suddenly plausible? You have to go back to a rule that is older than online shopping. In 1978, the Federal Trade Commission issued what became known as the eyeglass rule. The basic principle was simple after a refractive eye examination. The patient should receive a copy of the prescription. The prescription should not be held hostage until the patient buys glasses from the same office. That rule mattered because a prescription is not just a medical conclusion. It is also the key that lets the consumer enter the market. In 2024, the Federal Trade Commission updated the rule to strengthen compliance. Prescribers must provide the prescription immediately after the refractive examination. Under the updated framework, a digital copy can be provided when the patient gives affirmative consent. The patient can take that prescription to another seller. Think about what that means in engineering terms. The most important input in the production of prescription glasses can travel as data. The frame can be a digital model. The customer's face can be a three-dimensional scan. The lens prescription can be a structured file. The order can move without the object moving. Once those inputs become portable, the factory no longer has to be a giant building. It can become a machine. But first, the machine needs reliable measurements. And this is where Boston enters the story. Eyebot has developed a touch-free vision testing kiosk designed for retail environments. Its S1 Plus terminal gathers information such as refraction, visual acuity, and lens measurements. The data are then sent to a licensed eye doctor, who reviews the session and decides whether to issue a prescription. If the doctor approves it, the signed prescription can be delivered by email or transmitted to the retailer. The important word is doctor. Eyebot says the kiosk does not use artificial intelligence to write prescriptions. It collects data. A licensed professional makes the decision. The company also limits eligibility. Its retail system is designed for adults within a specified age range who do not have known eye conditions. And it does not issue contact lens prescriptions. In December of 2025, Eyebot announced that Walmart and Sam's Club had introduced automated vision testing kiosks in a pilot designed to provide eyeglass prescriptions in about 15 minutes. That announcement did not create a complete optical factory, but it moved the front door of vision care into a place where millions of Americans already shop. At almost the same time, another Massachusetts-connected company was shrinking the measuring equipment itself. Plenoptica's Quick See Free is a handheld autorefractor that uses wavefront-based measurement. The company says it can gather objective refraction measurements in about 10 seconds. It is registered in the United States as a Class 1 medical device that is exempt from the 510(k) pre-market notification process. Again, that does not mean a handheld scanner replaces an eye doctor. Objective refraction is an input. A prescription is a clinical decision. An eye health examination looks for problems that a simple refractive workflow may not detect. But the direction is clear. The equipment needed to collect useful optical data is getting smaller, faster, and easier to deploy outside a traditional exam lane. Now move from the eye to the frame. A conventional frame begins as inventory. A manufacturer chooses shapes. colors, and sizes before knowing who will buy them. Tools are made. Parts are produced. Frames are assembled, packed, shipped, displayed, discounted, or discarded. A retailer does not merely sell the frames customers choose, it also pays for the frames customers ignore. Three-dimensional printing changes that equation. Selective laser sintering can build strong nylon components layer by layer from a digital file. Eyewear manufacturers already use this process for prototypes, custom products, tooling, and end-use frames. A designer can change the bridge width, temple length, hinge position, or contour without creating an entirely new mold for every variation. That means a frame does not have to begin as an object. It can begin as instructions. Scan the customer's face. Measure the distance between the pupils. Map the bridge of the nose. Estimate where the temples should meet the ears. Let the customer choose a style. Then generate the frame for that person, instead of asking that person to fit a frame made for an imaginary average face. This is the point where most stories about printed glasses quietly skip the hardest problem. The lenses. A prescription lens is not a flat transparent disc. It is a controlled optical surface. Its curvature determines how light is redirected. A simple prescription may include sphere power for nearsightedness or farsightedness. Astigmatism adds cylinder power and an axis. The optical centers must align with the wearer's pupils. The frame angle, vertex distance, lens material, thickness, and coating can affect the final result. Traditional laboratories handle this with highly specialized processes. Lens blanks are selected. Surfaces are generated or finished. Lenses are polished, coated, measured, edged to the shape of the frame, and mounted. Modern labs are already heavily automated, but the equipment is designed around throughput, controlled conditions, and trained operators. ClearForge's fictional breakthrough is called fluid cast. Imagine two transparent membranes held inside a precision ring. Tiny actuators change the curvature of each membrane according to the prescription. Optical polymer is injected between them. Cameras measure the surfaces from multiple angles. Software corrects the shape before ultraviolet light cures the material. The lens emerges close to its final optical power and already matches the outline of the customer's frame. No circular lens blank has to be cut down into a narrow shape. No shelf needs to hold thousands of possible combinations. The machine stores raw optical polymer and turns curvature into software. That last sentence is the entire invention. Turn curvature into software. In our fictional scenario, ClearForge was founded in Rochester, New York, by three people who had spent their careers staring at different parts of the same broken chain. Maya Brooks was an optical engineer who worked on compact wavefront sensors. Luis Ramirez had designed automation for centralized lens laboratories. Dana Cho was an optometrist who built remote review protocols for rural clinics. Brooks believed measurement had become portable. Ramirez knew production had become automated. Cho knew neither mattered if the system encouraged people to mistake convenience for medical care. Their first prototype was not a retail kiosk. It occupied most of a garage and made terrible glasses. The early frame printer was too slow. The temples warped during cooling. The first fluid cast lenses developed microscopic ripples near the edges. A lens could match the requested power in the center and still produce distortion when the wearer looked sideways. The coating chamber trapped dust. The alignment robot mounted one lens less than a millimeter too high, which was enough to make a volunteer complain of a headache. That failure taught the team something the price disruption story often forgets. Cheap glasses that are wrong are not inexpensive. They are waste with hinges, so ClearForge added a verification loop. Every finished lens passed through an automated lens meter. The system checked sphere, cylinder, axis, optical center placement, surface defects, and frame alignment. If the result fell outside the approved tolerance, The machine destroyed the lens and started again. The doctor's digital signature stayed linked to the prescription. The machine's inspection records stayed linked to the finished pair. The second prototype separated speed from safety. The customer-facing scan took only a few minutes, but the software paused the order if the answers suggested flashes of light. Sudden vision changes. Pain. Double vision. Known eye disease. Recent surgery. Or a prescription outside the machine's operating range. Those customers did not get a fast pair. They got a referral. That is not a weakness in the system. That is what prevents a retail convenience tool from becoming a medical trap. By the time ClearForge built the fictional vision cell, the machine contained 5 stations. The first station collected history, visual acuity, refraction, and measurements from the customer's current glasses. The second sent the data to a licensed doctor. The doctor could approve the prescription, modify it after an interactive check, request more information, or refuse to issue it. The third station scanned the customer's face and generated a frame. The user could adjust color, rim thickness, temple style, and fit on a digital preview. But the software protected measurements that controlled optical alignment. The fourth station printed the frame and formed the lenses. Multiple components were processed in parallel, which is how the machine reached a median completion time of 21 minutes, without claiming that every individual manufacturing step took only 21 minutes. The fifth station assembled and inspected the result. A technician performed the final fit, checked comfort, and confirmed that the wearer could see clearly before the order was closed. Then came the number everybody cared about: the cost. In the fictional pilot, the optical polymer cost $1.85 per pair. Frame material and hinges added $1.10. Coatings and disposable supplies added $1.15. Remote doctor review averaged $3.50. Equipment depreciation, electricity, and maintenance added $1.40. Final inspection, fitting, and packaging added another $1.40. The total direct cost was $11.40. The retail price was $29. Notice what is not included in that comparison. ClearForge is not claiming that a luxury frame with licensed design, premium materials, specialized, progressive lenses, a global warranty, and a famous name should cost $29. It is comparing a basic single-vision product with another basic single-vision product. And it is not reducing the price because its plastic is magically cheaper. It is reducing the price because there is no finished frame inventory, no shipment to a distant laboratory, no second shipment back to the store, fewer manual transfers, and less capital trapped in products nobody buys. That is the real enemy of the current system. Not cheap material, idle material. In the fictional Ohio pilot, 6 regional pharmacies installed vision cells. Over several months, 12,400 adults entered the workflow. 9% were redirected to in-person care or denied a rapid prescription because of medical history, symptoms, measurement limits, or inconsistent results. Among completed orders, the median delivery time was 21 minutes. The remake rate was 3.8%. Some frames emerged with uneven color. A small number of wearers could not adapt to the first prescription. High astigmatism slowed verification. Strong prescriptions created lenses that were too thick for several thin-rim styles. On busy Saturdays, the promise of glasses while you waited became glasses after lunch. Those failures matter because they define what the machine is actually good at. ClearForge is not a universal replacement for optical care. It is a high-throughput system for routine single-vision cases within a controlled range. That still represents a large market. Think about the person who breaks a pair before a night shift, the student who cannot wait a week to see the board, the traveler whose glasses disappear with a suitcase, the rural worker who can reach a pharmacy but not an optical laboratory. the parent buying a backup pair for an adult child, the customer who simply cannot absorb a several $100 bill. For them, the important feature is not customization. It is time. The fictional pilot discovered something else. Customers chose fewer styles than the designers expected. When offered thousands of possible combinations, most people selected one of a small number of familiar silhouettes. What they changed was fit. A narrower bridge, slightly longer temples, more room near the cheek, a frame that stayed level because it was made for the actual face instead of an average generated by the factory. This changes what a brand means. In the traditional system, the brand is often attached to the object before purchase. In the ClearForge system, the object does not exist yet. The brand has to live in the software, the design library, the quality standard, the service, and the trust that the machine will make the same correct result every time. That is why the established eyewear industry would not necessarily respond by trying to ban the machine or pretend it does not exist. The smarter response would be to use the same architecture. A major frame brand could license digital designs. An optical retailer could place micro-factories near its busiest stores. A lens company could supply certified polymer cartridges and premium coating modules. An insurer could offer an emergency or backup pair through the kiosk while preserving a full annual eye examination in the benefit. The technology does not automatically destroy the incumbent. It gives the incumbent a choice between protecting the journey and owning the shorter route. Warby Parker already demonstrated that American customers would buy prescription glasses through a simpler direct model. iBot is demonstrating that vision testing access can move into mass retail. Plenoptica is demonstrating that objective refraction equipment can become portable. Additive manufacturing is demonstrating that custom frames can come from digital files. ClearForge is the fictional line connecting those real dots. But there is a line it cannot cross. A refractive test tells you what optical correction may help you see more clearly. A comprehensive eye health examination can look for diseases and conditions that may not announce themselves through blurry vision alone. Glaucoma, retinal disease, cataracts, diabetic changes, and other problems are not solved by making a sharper lens. The danger of a 20-minute system is not only that it might make a bad pair of glasses. The larger danger is that convenience might persuade someone to skip medical care. That is why every credible version of this future needs hard boundaries. Prominent disclosure, symptom screening, age and prescription limits, licensed review, referral pathways, data privacy, calibration records, manufacturing traceability, impact testing, optical tolerances, clear instructions that a fast prescription is not a clean bill of health. And then there are the rules. Optometry and telehealth requirements vary by state. A workflow that is legal in one jurisdiction may need a different professional relationship in another. The frame is a consumer product, but prescription lenses are medical devices. A new method of forming and validating lenses would need to satisfy applicable standards and regulatory requirements before national deployment. In other words, the machine is easier to imagine than the system of responsibility around it. Who is liable if the scan is correct but the lens is mounted incorrectly? Who catches a symptom the customer forgets to report? Who protects the biometric face map? Who verifies that a replacement cartridge has the optical properties promised? On the label, who recalls a production batch when a coating fails 6 months later? Those questions are not reasons the invention cannot happen. They are the invention. Because the company that wins will not merely be the one that forms a lens quickly. It will be the one that makes a distributed factory behave with the discipline of a medical laboratory. Now imagine the fictional timeline. Late in 2026. ClearForge completes the Ohio pilot and refuses to announce a national launch. The company says the remake rate is still too high for prescriptions near the edge of its operating range. In 2027, a second-generation coating unit reduces surface defects. The company adds a module for photochromic lenses but continues to exclude complex progressive designs. A regional health system deploys mobile units for communities where patients regularly wait months for routine refraction. In 2028, ClearForge licenses the manufacturing cell instead of opening its own stores. Pharmacies, employers, universities, and independent optical practices pay a monthly equipment fee. Doctors are paid for each completed review. Local technicians handle fitting and maintenance. By 2029, the price of a basic pair is no longer the most disruptive part. The disruptive part is that replacement glasses have become on-demand infrastructure. You do not choose from what the store predicted you might want 6 months ago. You choose from what the machine can make now. That changes inventory. It changes shipping. It changes fashion cycles. It changes rural access. It changes the value of a retail wall covered with hundreds of frames. And it changes the question consumers ask when they see a $300 price tag. The question is no longer, how much did the plastic cost? The question becomes, what am I paying this system to do that the machine cannot? For premium eyewear, there may be excellent answers. Craftsmanship, rare material, advanced progressive design, specialized coatings, a trusted clinical relationship, detailed fitting, service after the sale, a brand the customer genuinely values. But for a basic pair, the answer may become uncomfortable. You may be paying for the distance between the exam and the lab, for the frame that waited on a shelf, for the second frame that never sold, for the truck that carried the order, for the building that stored it, for the fragmented software that forced a human to type the same measurement twice. ClearForge does not eliminate the value of glasses. It forces every part of the price to explain itself. And that is why this is an American invention story, even though the finished company is fictional. The building blocks are emerging from a distinctly American combination of retail scale, telemedicina, portable diagnostics, direct-to-consumer commerce, software, and distributed manufacturing. Boston is shrinking the vision test. Federal rules make the prescription portable. New York companies have already demonstrated integrated direct retail and lab operations. Digital fabrication is turning physical inventory into files. The missing step is to put the lens factory inside the store. If that step arrives, the eyewear revolution will not look like a factory beating another factory. It will look like the factory disappearing into the wall. Go back to the customer in Ohio. The frame did not cross an ocean. It did not sit in a warehouse. The lenses did not travel to a central lab. The store did not guess the customer's size months before meeting her. The machine measured. The doctor reviewed. The software designed. The cell manufactured. And the technician verified. 21 minutes after the process began, she put on a pair that had not existed when she entered the building. The machine did not prove that every expensive pair of glasses is worthless. It proved something more important. The most expensive part of a basic pair may not be the material. It may be the journey. And once that journey becomes software, the eyewear industry will have to compete on what remains clinical judgment, optical quality, design, service, and trust. That is the real future ClearForge represents. Not glasses without doctors. Not medicine without responsibility. Not a magic printer that makes every prescription for everyone. A shorter chain. A smaller factory. A product made after it is sold instead of before. And a simple question aimed at an industry built around distance: if America can make the glasses beside the customer, why should the customer keep paying for everything that used to happen in between?